Okay, so in 3.4 we start off by doing number 8. So if we look at number 8, our function is 1 plus x squared to the 99th. So we first recognize the form as stuff to the 99th. That means when we take the derivative, it's going to be 99 stuff to the 98th times the derivative of that stuff. So I draw a line and say, look, the derivative is 99 stuff to the 98th times the derivative of that inside. So it's this derivative of the inside. So that's going to be 99, 1 plus x squared to the 98th times 1 plus 2x. And so maybe you write it as 99, 1 plus 2x. And really, there's not much simplifying you can do past that. So I'd say that would be your answer. That looks pretty simple to me. That would be number 8. So number 10 would be f of x is equal to 1 over the cube root of x squared minus 1. So the first thing I'd do is write it as 1 over stuff to the 1/3. But then I can bring it up into the numerator as x squared minus 1 to the negative 1/3. So that means the form of this thing before I take its derivative is stuff to the negative 1/3. So when I take its derivative, it's going to be negative 1/3 times stuff to the negative, what, if you take away 1, that's going to be 3/3, so it's negative 4/3 times the derivative of that inside stuff. So I draw a line so that you know I'm taking the derivative. It's negative 1/3 stuff to the negative 4/3 times the derivative of that stuff. So that stuff, its derivative is just 2x. So it's going to be negative 1/3 x squared minus 1 to the negative 4/3 times 2x. So if I was going to simplify that, I would have negative 2x on top all over 3 x squared minus 1 to the positive 4/3, and that would be my derivative. So then after 10, we do 12. So let's look at number 12. So 12 is g of theta is equal to cosine squared theta. Well, the first thing I do is recognize that that's cosine of theta squared. So the form of this thing is stuff squared. So its derivative is going to be 2 stuff to the first times the derivative of that stuff. So this derivative is going to be 2, leave the inside alone, times the derivative of the inside. But the derivative cosine is negative sine, so my derivative is going to be negative 2 cosine theta sine theta. That's 12. 14 would be f of t is equal to t sine of pi t. So if you ask me what the form is, I would maybe plug in something like 8. So if you plug in 8 here and here, first thing you're going to do is find you take 8 times pi, which is a number, then you take the sine of that, and then the last thing you do would be to multiply whatever you get over here times 8. And so since the last thing you would do is multiply, the form of this thing is stuff times stuff. So it's going to be the product rule. So this derivative is going to be the first derivative of second plus second derivative of first, where the first is t and the second is sine of pi t. First or second derivative of first. So then this derivative is really easy. That's just going to be 1. So this is sine of pi t times 1. But then I have to ask, what is the form of this thing? And the form of this thing is sine of stuff. So its derivative is going to be sine of stuff times the derivative of that inside stuff. You have to follow through with the chain rule. So that inside stuff is pi t times the derivative of pi t. So it's going to be t sine pi t times, well, the derivative of pi t is just pi, plus sine of pi t times 1. Okay, so you'd be done if it doesn't say simplify, but I think it's pretty clear that we have two big terms that both have a sine of pi t in them. So one term and another term. When you take out a sine of pi t, you're left with pi t plus 1. So that would be your function. And more than likely, so you don't get confused as to what you're taking the sine of, you'd probably move that sine over there, and that would be your answer. Okay, so that's 14. So now 16. 16 is g of x is equal to e to the x squared minus x. So this form is e to the stuff. So its derivative is going to be e to the stuff times the derivative of stuff. You must follow through with the chain rule. So this derivative is going to be e to the stuff times the derivative of that stuff. But the derivative of that stuff is just 2x minus 1. So that would be your derivative. If you wanted to make it really clear and not confusing, again, you'd probably move this out front so you don't get confused as to what's in the argument of e. But again, you can leave it like that. That's 16. Then we look at 20. 20 is f of t is equal to 3t minus 1 to the fourth times 2t plus 1 to the negative third. So when I look at this, I see something times something else. So something times something else. So its form is going to be stuff times stuff, which is the product rule. So the derivative is going to be first derivative of second plus second derivative of first. Here's the first, second, first. So then I ask, what is the form of this derivative that I have to take? Should be pretty clear that this derivative has the form of stuff to the negative third. So that means that its derivative, its derivative is going to be negative 3 stuff to the negative 4. Don't forget to follow through with the derivative of the inside. So it's going to be this times the derivative of that inside. Over here, this comes along for the ride. But then the form of this thing is just stuff to the fourth. So its derivative is 4 stuff to the third times the derivative of that inside. So let me do that over just a little bit. So there's going to be a 3t minus 1 in here, then times the derivative of that 3t minus 1. So that's going to be, I know the derivative of this thing is just 2. The derivative of this thing is just 3. So let's see. This negative 3 times this 2 gives me negative 6 out front. So there's going to be a negative 6 with a 3t minus 1 to the fourth on top, and a 2t plus 1 to the fourth on bottom, right? And then that's plus, over here, I've got a, let me do a different color, maybe a orange. Got 4 and 3. The 4 and the 3 are going to come together to give me a 12. But I've got a 3t minus 1 on top. gets cubed, and a 2t plus 1, what? To the third on bottom, right? If you wanted to have all of this to the fourth and all of this to the third, you could to make it simpler. And then I guess if you wanted to make it look a little nicer, you could get a common denominator if you just wanted to. Don't forget this down here is 2t plus 1. So if you'd like to get a common denominator, so you could stop there if it did not say to simplify. But then if you wanted to go a little further with a common denominator, you would hit this one with a 2t plus 1 over 2t plus 1. Right. And you could go from there. So let me go ahead and do that just for giggles. So copy. So again, if it said that you did not need to simplify, you could stop here. But if you wanted to go on, just to practice your algebra, this would end up being -6, 3t minus 1 to the fourth, plus 12, 3t minus 1 cubed, times 2t plus 1 all over 2t plus 1 to the fourth. But then on top I see two big terms, which both have a -6 in them. So that would leave a -2 here. They also both have a 3t minus 1 cubed. That would leave 3t minus 1 here. And it would leave a 2t plus 1 hanging out over there. All over 2t plus 1 to the fourth. So I think that's trying to tell you that all this stuff right here is going to be -4t minus 2. So it's going to end up being this with some of this. Then on top here, you're going to have -t minus 3 all over 2t plus 1 to the fourth. Right? So then maybe you take out, so you could just leave it like that, or you could take out a negative and make it 6, 3t minus 1 cubed, t plus 3, all over 2t plus 1 to the fourth. So again, that's just if you had to simplify. If not, that is a great place to stop back here. So that's 20. The last one we have to do is 26. 26, s of t is equal to the square root of 1 plus sine t over 1 plus cosine. I would first rewrite it as stuff to the 1/2. And I would let you know that my form is just stuff to the 1/2. So its derivative is going to be 1/2 stuff to the -1/2 times the derivative of that inside stuff. But the inside is just this. So this is what I'm going to have to take the derivative of. But notice that that's a new derivative, so its form just turns out to be stuff over stuff. It's the quotient rule. So I'm going to rewrite this as 1/2. Since it's a negative, I'm going to flip the sucker. But since it is a square root, I'm going to leave that root. 1/2 is a square root. So I've just rewritten all of this like this. Then over here, this form is low derivative of high minus high derivative of low. So to make it easier on myself, I'm going to write low derivative of high. Well, derivative of high, derivative sine is just cosine. Low d high minus high derivative of low is negative sine. All over 1 plus cosine t gets squared. So be careful. Should look like that, right? So if it asked you just to find the derivative, you would be done and you could stop there. Now, if it says simplify, you need to know how to simplify. So let's practice simplifying. So with this one, do you see that we're going to get inside here cosine plus cosine squared? And here, we're going to get, when we distribute this in, is going to be negative sine minus sine squared. But then we have this negative, so it's sine plus sine squared plus cosine squared. And then this comes along for the ride, right? But then you have memorized that sine squared plus cosine squared equals 1. So you have 1/2. And I'm going to break this up into 1 plus cosine to the 1/2 over 1 plus sine to the 1/2. And this is going to be 1, because that's what all that blue stuff is equal to up top, sine cosine, over 1 plus cosine t to the second. So then if I look at my exponents and I take 2, but I subtract 1/2 from it, that's going to be 3/2. So it's going to be 1/2, 1 plus sine. There's going to be a 1/2 here. But then on bottom, there's also going to be 1 plus cosine t to the 3/2. But then on top, we're just going to have 1 plus sine plus cosine. So that 1/2 is just going to put a 2 on bottom. So that would be what it looks like if you simplified. Cool. All right, that is it, because we just did number 26. That's all of it. We have a great day.